Hello children. Now in this video we will be discussing the application of valence bond theory so as to determine the hybridization, the shape, the magnetic behavior as well as the precise spin only magnetic moment of a coordination complex. Children, as you can see in this question, we are supposed to determine the shape, magnetic behavior, magnetic moment and hybridization of tetracarbonyl nickel. Now, a thing must be kept in mind that whenever only carbon monoxide is present as a ligand, need not calculate the oxidation state because it is always 0. So see, in NiCO4, nickel has the atomic number of 28. The oxidation state, as I discussed you, is 0. Now the ground state configuration of nickel is 3d8 4s2. Now we have 8 electrons in 3d orbital. 1, 2, 3, 4, 5, 6, 7 and 8. And 2 electrons are present in 4s orbital. Now we need to calculate the coordination number. Now the coordination number of nickel in this complex is 4. Now with a coordination number of 4, we must have 4 vacant orbitals to accommodate the lone pair of the ligand, which are not present there. Now we will consider whether the ligand is a strong ligand or a weak ligand. Now carbon monoxide being a strong ligand will force these electrons of 4s to pair up, and we will be having 10 electrons in d orbital now. These 2 electrons are promoted to the 3d orbitals. Now we have 4 vacant orbitals present over there. These orbitals can easily accommodate the electron pairs of carbon monoxide. Now 4 orbitals will accommodate 4 electron pairs, and thus we will get the hybridization as sp3. So first thing, we have determined the hybridization, which comes out as sp3. Now from VSEPR theory, you are supposed to memorize that whenever the hybridization is sp3, the shape will be tetrahedral. The shape will be tetrahedral. As far as the magnetic behavior is concerned, you cannot find any unpaired electron in the d orbital of the metal. So the number of unpaired electron n is 0. Therefore, the magnetic behavior will be diamagnetic. And children, you can see the formula to calculate the spin only magnetic moment written in the right hand top corner of the screen. Mu s is equal to under the root n multiplied by n plus 2, and the unit will be Bohr magnetons. Since n is 0, spin only magnetic moment on solving will come out as 0 only. Thank you. We have another complex of nickel on the screen. It is tetracyanidonyckelate. It is an anionic complex with a charge of -2. Now the central atom, when we will calculate, we will find out the oxidation state will come out as +2. Now with the +2 oxidation state and the atomic number 28, the valential configuration of Ni2+ will be 3d8 4s0. Although we have 4 orbitals available here and the coordination number of complexes is again 4, but cyanide being a stronger ligand will force these electrons to pair up, and we will be having paired electron in this orbital. Now we will count 4 orbitals to accommodate the electrons of cyanide. there will be one orbital from D, one from S, and two orbitals from P. Thus, the state of hybridization will come out as DsP2. Now, with the hybridization of DsP2, the shape will be square planar. The shape will be, children, square planar. As we can see in the valence orbitals of the central metal, we don't have any unpaired electron here also. So the complex will still be diamagnetic. Now, as there are no unpaired electron, n will again be 0. Now we apply the formula written on the right hand top corner of the board, and when you put n as 0, you find that magnetic moment again comes out to be 0. But remember, there is a very expected question from this part, where they say we have two complexes of nickel. One is NiCO4 and another is NiCN4. Both are having 4 coordination number, both have same central metal, but they have different shapes. One is square planar as on the screen, and you can refer to the previous video. We have one more complex, NiCO4, where the hybridization was sp3 and the shape was tetrahedral. So these two complexes differ in shapes due to difference in the state of hybridization. Tetracarbonyl nickel is sp3 hybrid, whereas tetracyanidonickellate is dsp2 hybridized. So this is much expected question in the board exam, children. Please be very careful when you write answer to such questions. Now children, we have a third complex of nickel on the board. This is tetrachloridonickelate. Now again, the oxidation state of nickel is +2. Again, the valence shell configuration will be 3d8 4s0, and we have 4 vacant orbitals already present over there. But we will still consider whether the ligand is a strong ligand or weak ligand. So you cannot find carbon, oxygen or nitrogen in this ligand. So this is most of the cases not likely to be a strong ligand if you don't remember the spectrochemical series. If you remember the spectrochemical series, you can clearly say that all halogens are the weakest ligands. So chloride, being a weak ligand, will not force pairing of electron. So these electrons in d8 orbital will not get paired up like we did in tetracyanidonickellate. Here it will be unpaired only. But still we have 4 orbitals present which can easily accommodate 4 electrons from chlorine. So we are going to get the hybridization as sp3 hybridization again. Now hybridization being sp3, the shape will be tetrahedral again. Tetrahedral again. But as we can see, we have 2 unpaired electrons present here. Now these 2 unpaired electrons will impart paramagnetism. So the complex will be paramagnetic. N is equal to 2. Now we will be putting the value of N as 2. So we get it as under the root 2 multiplied by 2 plus 2, which is equal to under root 8 or 2 root 2.